Hi, my name is Rong Lu, and I am a program manager on the Visual Studio team. In this video, I'm going to show you how to use the GPU usage tool in Visual Studio to collect and analyze GPU usage data of DirectX applications. Here are the topics we're going to cover today. I'm going to first introduce to you what the GPU usage tool is. Then we'll get into a demo to see the tool in action. At the end, I will share some resources if you're interested to get more information about this tool. During the development phase of games, it's not uncommon to encounter performance issues, where the apps couldn't hit the target frame rate, whether it's 60 on the PC or 30 on smaller devices. The cause of performance issues in DirectX applications can be complex. So this is where the GPU tool can help. By collecting and analyzing GPU usage data, the GPU usage tool can provide insights into what's going on the CPU and the GPU, and therefore can help you to determine whether the CPU or the GPU is the performance bottleneck. This tool is available in both Visual Studio 2013 Update 4 and Visual Studio 2015. Now let's get into a demo to see how this works. In this demo, I will show you how to use the GPU usage tool to figure out where the performance bottleneck is in my DirectX application. Here I have Visual Studio 2015 open, and this is a DirectX application. I already know beforehand that this app is not hitting the frame rate I'm targeting, which is 60 frames per second. Now let's launch this app with the GPU usage tool so we can collect some data to understand what the problem is. To start off, I'm going to go to Debug menu and select Start Diagnostics Tools. From here, I can pick the GPU usage tool to run by itself, or I can run additional tools along with it. I'm going to collect CPU data in this case as well. So here's my app. It's a 3D app of a city. I render many buildings along with 6,000 raindrops in each single frame. As you can tell from the left side, there's a frame rate. This app is running at 51 frames per second, but just couldn't hit the 60 quite yet. Let's go back to Visual Studio and see what Visual Studio is doing. At this point, when the app is running live, we are showing a few live graphs, including frame time, frame rate, and utilization data for the CPU and the GPU. Let me stop collection for now, and we're going to look into the details. Now Visual Studio is finishing up processing all the data and is going to generate a report for us. Okay, here's the report. As you can see here, this is the frame rate. The red line represents 60, which is my target, and our app is not quite there yet. On the utilization side, my GPU is pretty busy most of the time. It's over 80% used, but the CPU is only 11% used. In some cases, you might be able to tell right away from looking at these graphs whether the CPU or the GPU is causing the problem. But in other cases like this one, we can't say for sure yet whether the CPU or the GPU is the bottleneck. So let's take a look at some detailed data. I'm going to select a range in the timeline. This app runs pretty flat, so I can click anywhere and view details. Here's the GPU details view. Let's take a look at the table down here first. Basically, this is a list of all the events, DirectX events that were executed on the GPU. We collect the name of the event along with their CPU and GPU start time, how long it took on the GPU to execute, which thread, CPU core, or GPU engine it was executed on. Up here is a visual representative of the same data down here. We have lanes for each CPU core as well as GPU lane. The blocks on here represent execution time of my program. Different colors represent different processes. You can interact with these graphs by clicking anywhere on the graph. In here, I've clicked on a draw event, and you can actually see when the draw event starts to be executed on the GPU and how long it took. You can also see when the corresponding CPU call happened on the CPU side. Now you can figure out how long each draw call takes by just navigating through these graphs. Other things to point out on this graph is these vertical lines. These are vertical sync time of your display. Usually it's set to 60 times per second, which means for the app to hit 60 frames per second, both CPU and GPU have to complete all the work for frame rendering within 16 milliseconds, which is what these lines stand for. Between every two lines, this is representing 16 milliseconds. Now let's take a look at the execution of this app. Okay, let's take a look at the section here. So the P's we have here are marking where the present calls happen. This is when it happened on the CPU, when the API call happened. This is when GPU has finished all the rendering and is ready to present. Of course, nothing is going to be on the screen until the next vsync happens. As I mentioned earlier, for the app to hit 60, each frame has to fit within 16 milliseconds. Now this P marks the end of the previous frame, and this is the present of this current frame. So basically between the two P's, this is how long this frame took, which apparently you can see in this app is exceeding the 16 milliseconds budget we have, because it's longer than these two lines. So from here, we already know that this is a CPU bound problem. We can navigate through the events to find out which event is causing the trouble. But since we also collected CPU usage data at the beginning of this session, we can actually look at per function call of the CPU usage data. Let's switch to the CPU usage details page. I'm going to keep drilling into this tree view until I find the function that's using most of my CPU. Looks like it's right here. This commit updates function is using almost 70% of my CPU time. Let's take a look at what it does. I'm going to go into the source code. Here's my commit updates method. The key function of this method is basically a for loop for the CPU to prepare data for each single ring job. As I mentioned, I render 6,000 ring jobs in this in one frame, which means this for loop is going to iterate for 6,000 times, which means we might have an opportunity here to parallelize the work onto multiple CPU cores, because we learned from the GPU usage page that only one CPU core is being used at a time. Although I have 8 CPU cores on my machine, 7 of them are not used at all. So let's try to parallelize the work. What I'm going to do is I'm going to replace the for loop with a parallel for loop. Parallel for is a method that we provide in the parallel library that ships in Visual Studio. Basically, it's doing the same for loop, but it's going to automatically patch all the work to multiple CPU cores to leverage all the resources on my machine. Now I'm going to rerun the app and see if we get any performance gains. Hey, here we have the app running again, and our frame rate has jumped up to 60 frames per second, which means the CPU and GPU are both doing their job, so we can finish every single frame within 16 milliseconds. In the demo, I showed you how to use the GPU usage tool to understand the GPU usage of a DirectX application, and how you can use the data to determine where the performance bottleneck is. Hope you have enjoyed it. Here is a blog post where you can find a detailed introduction of this tool. And if you are interested in hearing more updates on this feature, please follow the Visual C++ team blog. Thank you for watching the video.